Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we are going to cover lists in Python. As we discussed in the previous video, list is a data structure and perhaps one of the most applied and useful ones. In this video, we are going to actually see how lists are created in Python and what are the functionalities, a few of its functions, and how it's used for different purposes. And of course, we're also going to see in this video how we can use lists to simulate stack and queue, and we'll finish the video by talking about array and matrix. Alright, let's look at the video. So as we discussed, lists in Python, just the way you define them is by specifying your collections of items using a bracket. So let me start by saying my object is equal to this specific way of creating collections of items. I would say 20, 15, hello, 2.3, false. So this is a list. I specifically called it my object, so I can go ahead and use the function type to tell me what's the type of this, my object, right? So the type is list. Pay attention, we never specified this for Python. We just started using brackets. So whenever you use a bracket and you have some collections of items, it just creates a list, right? So for instance, now I can say my list and create this list. And once I say my list, now it's going to return this form. Another thing is I can have empty list, right? So I can say my list. This time, just specify this, just an empty list. So if I say what is the type of this empty list, this is still going to be a list. So you can see it's very simple. You just start by brackets, putting stuff in, and you've got yourself a list. So how do we access different elements in the list? It's very simple, right? So for instance, this list. Let me copy it, right? So I've got this list. Now I want to access this. Lists are indexed using 0, 1, 2, 3 integer indexing. So if this is the index of the first element, it's going to be 0, 1, 2, 3, so on and so forth. So if I said my list bracket, open bracket, close, and put the index 0, it's going to give me the first element. The second element can be accessed by saying 1, and so on and so forth. So this element can be accessed by 0, 1, 2, 3, 4, 5. 53. One thing you want to pay attention, if you were to use negative index, it starts from the back of the list. So I can say my list, -1, it gives me the last one. If I say my list, -2, it gives me the same thing as this one, right? So it starts to count from the back, which is very useful. We will see an example how they can be useful. So next we're going to cover the function append. We did talk about this function during the previous video, but now let's see how it works. So I've got this function of my list, right? So my list, I want to append a new thing to it, right? It could be a number, right? You run, and once you run, it looks as if nothing has happened. But rest assured, when you print your new list, you can see the new items have been added. You can add other things. It doesn't have to be numbers, right? You can add hi. And again, if you run your list, you can see hi has been added here. And a lot of times you might want to create our list in a loop, right? So we can certainly do that. So for instance, I say my list, I create an empty list, and then go through a loop. Let's have a loop I in range 200, not 210, let's call 11, and let's append the 2 power to I. So I want to have 2 power to 0, 2 power to 1, 2 power to 3, all the way to 2 power to 10. And once this is done, show me my list. Let's see what we will get. We'll get these numbers as expected. So we can create our list using a loop. This is a normal way of using a loop. Using a loop to fill up a list. We can also use something more sophisticated and perhaps more concise and sometimes very useful as list comprehension. List comprehension is the way you would fill up a collectible, including dictionary, lists, and other types of collectibles, by just in one line of code, right? So let me just do the same thing I did here and just do it in one line of code, right? So I would say my list, and I would have bracket open, bracket close, and then I would say I would say what I actually want here, 2 power to I for I in range 11. So once I run this is going to do the same thing here. So I'm not going to go heavily over this list comprehension thing at this point. It's something that you want to perhaps sort of look into it yourself now, or a little bit in the future after you start feeling more comfortable about programming. But just knowing that this is something you can work on and you can learn is great, because you can have more than one iteration, you can have nested loops, and you can do a lot of different useful things in just one line of code. But the gist of it is this simple list comprehension is basically saying, I have this iterable and this is what I want to calculate, and do this in this loop, right? So that's basically what this list comprehension is saying. But let's move on. And let's talk about the function len. It's basically short for length. Whenever you want to calculate the length of something, whatever it is, Python has got you covered. So I can say, what is the length of this list? And it tells me it's 11, right? So there are 11 numbers here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Another thing we want to learn here is how we can sort of loop through a list. This is something we have seen before, but we want to learn here. We want to learn to also keep an index when we go through the list in a loop, right? So this is what we already know. So for instance, I can say for num in my list, right? And I can print num, right? This is I can do. But now I want, my program or my solution needs for me not only to have these numbers, but also I want to have the index that these numbers are in this list, right? So I can do something like this. I can do, for instance, I can say for I in range, length of my list, right? So I know the length, and then I can print I, so I have access to I, but also I can print or show my access to those values, right? By my list I. So I access 0, 1, 2, 3, so on and so forth. So let me also put a divider here, so my code will look nice and clean. So I can see the index, the value, index value, index value, so on and so forth, right? So that's one way to go about this. There is an easier and cleaner way actually. So that easier and cleaner way has this syntax. So you would say for I an item, right? And next you would say enumerate your collectible. And in here my collectible is my list. And now I have print item. Pay attention. Now I don't have to access the list, right? The item is in the item, right? So this is going to actually give the same result. Let me copy this and print. I'm missing in, right? So this needs to be here as well. All right, so we get the same thing here. You might rightly ask, Roy, what is this enumerate? Enumerate is an iterable. It creates iteration using a collectible, right? So let's just do it and see what it is. So if I were to run this, right, let's see what we get. It says it's an enumerate, right? So any iterable can be sort of like accessed using a few functions, right? So let me call this my enumerate, right? And by using the function list, I can list my enumerate, right? Right, so it tells me all of the enumerations, right? So it lists all of them. I didn't have to do that. I could also use the function next, right? So I create this again, and then I find the function next. Basically, it starts giving me all the iterations of my function, right? You see? So if you continue saying next, right, you will get all of them, right? And at some point, you will run out of the iterations. And once that happens, you get an error. And the error says stop iteration. This is the error that we talked about. In the video, we talked about errors. So that's basically it, right? So we are using this enumerate function to have a nicer and cleaner loop through a list. We've got the item and we've got the index. All right, let's continue. Function reverse. The function reverse just reverse your list, right? So let me say my list dot reverse. So once you run this function, it looks like nothing has happened, but it has actually reversed the list itself. So if you were to run the list again, now you will see list has reversed. Function extend. What if we want to just add more than one value to a list? I mean, we can add a value to a list by using the function append. How about we want to do two, right? So for instance, here I want to add. Let me reverse my list one more time first. So I have the normal list. So this is the normal list that I want. So now I want to append just more than one item. So how about I say, how about this, right? So once I add this, you might think that this has done the trick, but once you see it, you will see that now you have list inside the list, because the function append does not allow you to add more than one item, just one item at a time. When you want to do something like this, the best way to go about this is to use the function extend. So let me recreate my list using the list comprehension, right? So 2 power to I for I in range 11, and now this time let's see what it is. So let me see our list updated. Now this time let me use the function extend and now add these 2 items. So once we run this, now we ought to be okay now. So on my list, those item has been added as just part of this list, not as a list of lists. The next function we're going to talk about is the function index. This function basically tells you the index of your list, an item in the list. So for instance, you can say my list dot index 64, and it will return the index of this value in your list, right? So my list, this 6 is going to return 64. What's going to happen if that number is not in the list? It's going to give you an error, right? So if you run this, it's going to give you an error, value error. That number is not in the list. The next function we're going to talk about is the function insert. The function insert is going to allow you to just do more than what append does. What append does, it adds the new item at the end of the list, right? But with insert, you can actually decide where exactly, what part of the list you want to put the item in. Remember, list is an ordered collection of items. So here I can squeeze in a value. So my list dot insert, and I can, for instance, say I wanna enter something like this. Oops, in the third index. So once I run this, actually these are the third index. I want to add oops. So now once I run this, oops been added here, right? So that's how it works. I could add something in the beginning of it. So for instance, I can say my list add 0, add 0 to the index 0. So once I run this, now 0 has been added to that part. There we go. Another function is very useful, function pop. We're going to use this function when extensively when we want to simulate stack. We'll see how it works. But basically pop will pop or extract the last item on the list, right? So the last item on this list is this value, 4096. So if I say my list dot pop, it's just going to pop out this value for you. So pay attention, not only is going to pop out this value, if you look at your list, this value is not going to be in your list anymore. So my list, this value is not going to be in there anymore, right? It's been popped out. So if you run this a few times, you keep popping out values from your item. Alright, so next function is sort. Before we do this function sort, let me actually make sure that everything is just a number here. So let me just get rid of that oops. So I'm going to use the list comprehension to recreate my list. Let's do here, so that's the list comprehension. Now I can simply say my list dot sort, and it looks like nothing has happened, but it has actually sorted the list. But this is already sorted. Perhaps we can first reverse this, right? Right, so perhaps we reverse this, and also let's, for good size, insert a big number on this part, on index 5, and another very small number on index 10. And let's run these two, and before we want to do sort, we want to see what's happening in our list. So you can see that large number and small number. Now if we were to sort of like use the function sort, now you can see that this has been done, this has been sorted nicely, right? So now we've got some stuff that we don't want. We don't care for these to be here and these to be here. We want to remove some stuff here. So we can use the function remove. We'll be removing, specifically a value. So for instance, I can say my list dot remove, and once I run this, that value has been removed, right? If you want to remove something that is not in your list, you're going to get an error, value error. And let me create an example. If you want to remove something that has been repeated in your list, so let me create a list that has repetition. Right, so we've got 2. If we were to remove 2 from here, it's going to remove the first one, the first 2. Right, so let me run this. Let me show this here. Right, so if I remove 2, it's going to remove the first 2. See, that first 2 has been removed. Another useful function of lists is a copy. As you've been paying attention, every time we do any of these functions to a list, it changes the original list, right? So it doesn't output a new list, it changes the original list. So what if we want to keep that original list intact, right? So for instance, I have this list, this one, and I don't want to let the value change, right? I want to have this list exactly as it is, but I still want to work on this. So I could say my list 2, and then just get a copy of this. So now if I were to do a lot of stuff on this list, pop some item, remove some item, I don't know, add some item, and all of that. So let me run it one more time. Okay, let me run it from the beginning one more time. So now if I were to say my list 2, all of those changes have been applied here. But if I were to say my list, my original data is intact, right? So I've been able to keep that from being changed. So that's the way you would use the function copy. Another function that is useful is the function count. It can tell you the number of one of these elements. So for instance, the number of 2's, you have to say that count. The number of 2's is 7. How about the number of 1? Is 1. If you want to count it in something that is not in the list, it's going to give you an error. Oh, actually it's going to give you 0. It's not going to give you an error because the number of times that this number has appeared is 0. Alright, so let's look at an example to put this, what we've learned, into use. So we've got a list of states. It's actually a list, programming list of the United States states. and we want to use a loop to create a new list, right? We want to create a new list that has all of the states that starts with the letter M, right? So we want to use this list to do this. So the first thing we need to do in these situations, we want to create a list that we want to append stuff to, right? So we want to append some of the states name into this list, right? So I create an empty list. Then I will go over all of my state in states, right? And then if state as string for, so the first character is M, then append that state to my M states list. So once all is done, now I should be getting my new list with only state. Only states that starts with M. Alright, so now let's see how we can simulate and stack using a list. So remember the way stacks work. Stacks work like a stack, right? You have a collections that you can only put stuff from the top and also take stuff from the top. So we can pop and push. So let me create an example first. So let's call A is equal to, I'm going to use list comprehension to create sort of like a list of tasks or a stack of tasks. So let's call this letter dot format I. Basically this is going to change based on what I have here, similar to what they had done in the previous list comprehension in this video. So it's going to be for I in range 10. Let's call it 7, right? So now this is a stack, right? So we want to sort of like only take stuff from the top, and so we don't want to sort of do anything else. We just want to do this. So we only push or pull. So let me go ahead and reverse this. Right, so now I can say a.pop right, and now if I look at A, letter 0 has been taken care of, right? So if I say another time a.pop, another time a.pop, right, letter 2, letter 1 are taken care of, and then if you look at A, it's the stack is becoming smaller just because we're taking care of stuff. How about if I wanted to push? I wanted to add something on top of this. The way we would go about this is, of course, using the function append. Yeah, so I would say a dot append letter letter 7, and once I run this and check out how A looks like, you see now this has been added. How about another letter to the top of the pie? Append. So basically by using the function append and pop, we can basically simulate the working of a stack in Python, right? So now we can also start popping stuff again. So a pop, then the last item is going to pop, which is letter 8, right? So this is the way we could simulate using stack, using a list for a stack. All right, so let's look at an example together. So in this example, we want to use a stack to, actually using a stack is the best way to go about this, but we want to sort of like check if the brackets and parentheses in a formula is okay, right? So for instance, this formula is okay. I mean, this bracket opens and then this parentheses open, the parentheses close at the right time. You know, the bracket then closes. This is not okay because it starts by closing and there is no open parentheses. This is also not okay because before the bracket closes, the parentheses has closed. So this doesn't make sense. So we want to make sure that everything looks great using code. We don't want to do this by our eyes or our understanding. We want to do this using a code. So this is the formula, and since this video is getting long, I'll just copy the code that I had done before and go over it. So this is the code that will do the trick. So this is our formula. So let me run this, and first I say what are my open symbols and then what are my close symbols. And this is my stack that I'm going to be using to evaluate this formula. And in the beginning I say, okay, I assume everything is okay. And if I run into some problems, I just say, hey, there is something wrong here. So I go through all of the symbols in this formula, and if that symbol is either in the open symbols or closed symbols, I engage. Other than that, if I come across anything else, I just say, okay, it doesn't matter to me. So if I engage, means that it's either one of these symbols. And if there is nothing happening, it's empty, right? So this checks that this is empty. Then, and also if it's a closed symbol, right? Like example, like this situation, you cannot start with the closed symbols. Then I say result bool, which was the result is false. It means that this is not correct, and I don't need to check any further. So I break the whole loop and go all the way to printing. But if that's not the case, if it's not an open close symbol, it's actually it has to be open symbol. So I add this to a stack, right? So I add this to that stack that I want to use for evaluation. And if it's else if it's not empty, if it's an open symbols, I add again to the stack, right? So every time it's an open symbol, I add it to the stack, and then I check if any closed symbols come, and then I check if this is the same closed symbol as that one, right? So in this part, once the closed symbols comes in, I check that the closed symbols is the same as the one that is, we are checking the last one, or if it's this one, it's going to correspond with this one, and so on and so forth. So by these codes, I can sort of like make sure that the formula looks great as far as the brackets and the symbols. I have a print check stack to sort of see what's happening during our loop. So in the first few symbols, nothing is happening, right? So these are none of the brackets. So I start with this and then this, right? And then this. These are all open, 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 and then I start checking all of these, right? So open, 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 and then after that I start sort of checking and checking, and it seems that everything looks good, right? So this is an okay symbol. This is an okay formula. I could have actually used this. You created function here, right? I mean, I know we haven't talked about functions yet, but let's just use it here. And once we get to talk about functions, of course I'm going to talk about them more fundamentally. So all I need to do to make this into a function is a few changes, right? I can say define check formula, and my input is formula, and then make sure all the indentation is correct, and actually I'm going to need these as well. So let's make sure all the indentation is correct, and instead of, I'm not going to need this print. Instead of printing, I just return, right? So that's how a function works. So now if I define this function, I can keep using the same function for different formula, right? Of course I can use it for this formula that I had here, right? So I can use it for this. So let me copy it. It's going to give me true, but if I were to mess this up, right, in any shape or form, it's still true. It's going to be false, right? So I can, sort of like create this formula and use this forever. That's the way functions work. But we're going to talk about them at more length in the future videos. Alright, so here how we simulate a queue using list. So I create a list, I call it queue. It's an empty list. And every time I want to enqueue or add an item to the queue, I will use this function, the function insert, in this way. I will add the value into the beginning of the list. I will say insert 0, and then I will add, let's imagine it's actually a line, so customer 1, right? I keep adding with this specific syntax, insert to the beginning of the list. So customer 2, let me add a few customers, customers 3, 4, 5, and 6, right? I have to create this, and then I say queue.pop, right? Customer 1 is taken care of, so I can see, I can add some more customer. This is exactly like a line, right? So there is one server, and customers are piling in, and then you can see your queue is getting longer, but the order is not missed, right? So if you say pop, now your person who was in the line is going to be taken care of. Alright, so lastly we are going to talk about array and matrix. Array is a list of numbers, right? So for instance, if you have my list and everything is just numbers, right? Whatever numbers, floating point or integer, doesn't matter. So this is an array, in definitions, but we can actually do better than just using a list. By that I mean we can import numpy module, which stands for number, Python numpy, as np, and actually start using the array functionalities of the Python, right? So if I were to run this now, this is the actual array. So now I can have things that Python itself, I have to give this a name, np, for instance, a Python itself might not have. For instance, I can calculate the mean, or I can calculate the standard deviation. Python also allows you to have matrices or matrix. So for instance, here I can say np.ones and create a matrix of 4 by 5 ones. Or zeros, right? Whatever I want. 10 to 5 zeros. So if you are used to programming in MATLAB, you might miss matrices in Python. But NumPy arrays has very useful matrices that there are functionalities and operations that very similar to MATLAB can be done. Alright, in this video we talked about lists. We saw different functionalities of lists in Python, and we saw a few examples that bring the point home for you, why those functionalities are important. And most importantly, we simulated stack and queue using lists in Python. In the next video, we're going to cover dictionaries. It's going to be another very important data structure that we're going to learn about.